Hello everyone, welcome back to my math channel online again. Follow up with my previous video, we still talk about the topic of the composite function and its domain and range and whether or not the composite function exists or not. So in this video, I would like to continue with that. So let's take a look at the question 1 on the board here. So on the board here, I have the question 1 say given f of x equal absolute value of 3 of x. So this side is for absolute value. And another function g of x equals square root of minus 7x. So this is the radical function. For letter A, it asks to find the composite function f of g of x and state if a composite exists or not. And of course, explain why, the reason. So let's first identify which is the outer function and which is the inner function. So we have a function f of g of x. So the inside here is the inner function. So g of x is the inner function. And we want to find this function. So first, let's find the domain of g of x. So domain of g of x is we have to know that minus 7x have to be bigger or equal to 0. So minus 7x have to be bigger or equal to 0. So what does it tell us? We're going to twist this so it becomes positive 7 of x have to be less than or equal to 0, which is x have to be less than or equal to 0. And it's true. If x is negative, you multiply with minus 7, it will become a positive. But if you leave an x is a positive, bigger than 0, then you tie this, it will be negative, and we not except for the member inside the square root is negative. So domain of g of x is a set of x such that x have to be less than or equal to 0. So this is domain of g of x. Now we're going to find the composite function f of g of x. So f of g of x will be f of g of x will be equal, fx is the outer function, so we will have the absolute value inside, we have a 3, and then x inside here will be substituted by the square root of the g of x, which is minus 7x. And we close the absolute value. So what is the domain of our new composite function? The domain of our new composite function is exactly the same, right? So domain for the new composite function will be exactly the same like this one, right? Same. And yeah, so if we draw this function on the coordinate grid, we will have an absolute value function, something look like this. So this is the absolute value function. Now the function g of x is the square root function, and it only exists when the x here is negative So this is the function g of x. So our new composite function will be exactly the same, except that any y value will be higher than this multiplied by 3. So if you pick up a number here, the y here is 1, but then it will become 3 somewhere, right? So this point will go up here, something like that. And this point will go up here, something like that. So at the end, our new composite function will have a shape look like, so let's see. Our new composite function will have a shape somewhere like this. So this is the f of g of x function, which is this one. And the domain of it, yes, the same, x have to be less than 0. So it means if x is bigger than 0, then f of g of x does not exist. So if x is less than 0, then yes, it exists and it shows this is the function. But on this side, it doesn't exist. So it does not have a function. So that's the idea of the letter A. Now let's work on the question B now. So for the B, we're going to do reverse. We will do g of f of x. So first, we know that the domain of g function of gx, the domain, right? Domain of g of x. So the domain of g of x is the set of x such that x have to be less than or equal 0, right? The same function like this. Now the f of x, the domain of f of x. So domain of f of x will be, because this is the absolute value, so 3 of x have to be, sorry. So the x here can be any real number. X can belong to real number, right? Because the x here can be negative as well. But after we take out the absolute value, it becomes a positive. But for the x exit, and you can see that the absolute value exit both sides, right? So x can be negative or x can be positive as well. So that is the domain of f of x. So now let's find out the G composite function first. So G of f of x. So this time the f of x will be inside the function and the G will be an outer function. So we will follow the G expression will be equal minus 7, but the x now will substitute by the absolute value. So 3 of x. So after we got the composite function, what does that tell you? It tells you that in this situation, right, in this case, minus 7, we know that 3 of x is always positive, but minus 3 of x absolute value is always negative, less than 0. So we not allow for the radical to have a negative function, so that it tells us that g of f of x does not exist. So if we find f of g of x, then yes, it exists, but only exists when the x less than 0 on this side. If we find the g of f of x, it tells us this function does not exist because no matter this is the absolute value positive, but the -7 will make it always become a negative. And therefore the function does not exist. So now let's check about the domain of g of x. We say that the domain of g of x here is x have to be less than 0. So x have to be negative. But if we place the x inside the absolute value, yes, the x can be negative or positive, but no matter what x positive or negative, we multiply with -7, it's always become negative. It's always less than 0. So it does not matter. It does not matter the domain of g of x, what it is. So it does not matter the domain of g of x, what it is, right? The important thing is the domain of f of x, the inner function. So after we done the question here, and those questions before in my previous video, what is the conclusion we can withdraw? The conclusion that we can withdraw that the definition of the composite function, right? The definition of it. And the definition of composite function say, definition, if f of x and g of x, if f of x and g of x exist, and f of g of x is a composite function, then the domain of g of x is for on x such that the domain of g of x is for on x such that on x of g of x is also the domain of f of g of x. So basically, let me read the definition so that maybe it is stated in a better understanding way. Okay, so I don't have it here. So basically, it say that if we have a composite function exists, then the domain of g of x, the inner function, is also the domain of f of x. For on x such that the domain of g of x is also the domain of f of g of x. But let me sorry for a minute. let me read the definition to you to make sure that the statement here better than the statement I make on the board, right? So for the composite function f of g of two functions, if f and g is defined by f of g of x, then for on x in the domain of g, such that gx is in the domain of f. So basically, it's the same like the statement I wrote it on the board, but maybe it stayed in a better way. That's why I want to read it out loud to you. So let me say it again. For the composite function f of g of two functions, f and g is defined by f of g of x. Then for on x in the domain of g, such that g of x is in the domain of f of x. So in this example here, you see that it doesn't matter if we have an outer function g of f of x, and we state the domain of outer function, which is x have to be negative. And then we find the g of f of x. But doesn't matter, we restrict the domain of g of x. It does not matter for the domain of g of x is exist or not. The matter here is an inner function. In this case, the domain of f of x is not satisfying the composite function. So it doesn't matter the domain of the outer function exist or not. It does not matter. The domain of inner function is the important because the domain of f of x here is not satisfied. The domain of the inner function is not satisfied. Therefore, the whole composite function is not satisfied. So basically, the domain of the inner function is a factor decide the composite function exists or not. So from now on, when we do the composite function, we will restrict the domain of the inner function, and we will state the restriction of the domain of our composite function. So let's do the question 2 here, and you will see how we're going to do this. So let me show you how we do question 2 here. So given fx equal 3x divided by x minus 2 and gx equal 5 minus x. So to have f of x defined, right? Fx is defined if first we have to make sure the function valid first, right? X have to be different from 2. For g of x is defined for on real number, right? Because this is the linear function, so g of x is defined for on real number. So now let's find out f of g of x. So we do A, and let me iterate this down here as well. So we're going to do find f of g of x. So f of g of x will be equal, the function outside is f function. So we're going to follow this. So we have a function, rational function. On the top will be 3, but the x here will be replaced by the whole function here, 5 minus x. So I'm going to substitute this x by the g of x here, 5 minus x. Down here, this x will be substituted by 5 minus x again, 5 minus x. So the x here will be substituted by g of x as well, and minus 2. So let's simplify this. This will be equal 15 minus 3x on the top, right? Multiply through. Down here will be 5 minus 2 is 3 and minus x. So this is the new f of g of x. So now let's find out the domain of our new function. So first, we know the domain of g of x is for all real number, right? That's the important thing. We say that domain of g of x is on real number. So first we have to find the restriction for domain of the inner function. So first is the domain of g of x is on real number. Now we find the domain of the composite function, domain of f of g of x. So this domain will be minus x cannot be, so 3 minus x cannot be 0, right? Down here, this cannot be 0. And therefore, move it over, 3 cannot be x. So the domain of this is a set of x such that x have to be different from number 3. And x can belong to real number. So except for number 3, the x here can be any number, but cannot be number 3. That's the domain of our new composite function. So that is done for question A. Now let's do question B. So B will do opposite. We'll find g of f of x. So g of f of x, the g will be the outer function and the f of x now will be inner function. So follow the expression g of x equal 5 minus x. So it will be equal 5 minus the x here will be replaced by the whole thing of the f of x. 3x over x minus 2. So this is the new composite function of g of f of x. And the domain of this new function is the set of x such that of our new function, new composite function. The domain of this will be a set of x such that x cannot be equal to. Other than that, x can belong to the real number. Okay, so what about the range of this function? Now this is a rational function, so it looks like this function, if x equals 0, y equals 5, so this function go to, let's say 2, 4, 5 here. And we have a vertical asymptote at x equals 2. And the horizontal asymptote will be 5 minus 3 here, because that's the horizontal asymptote, 3. So 5 minus 3 is 2. So look like the horizontal asymptote is here. And look like this is the shape of our rational function. Something like this. So the range of our rational function will be equal. What is the range of this function? the range of this function will be on the set of y such that y can be negative infinity or positive infinity, so y belongs to real number, except that y have to be different from value 2 here. What else is restriction for this y function? Yeah, so y cannot be 2. And that's it. So that is our composite function and how we state the domain and the range for them. So this content is a little bit complicated, but I think that I make it very, step by step. So hope that it be helpful. So thank you for watching, and bye for now.